So, sorry for that. The presentation is about the ICME project. ICME stands for Integrated Coastal Monitoring of Environmental Problems in Sea Region and the Ways of their Solution. It's part of the Black Sea Basin Joint Operational Program of 2007 and 2013. Partners of this project is the Municipality of Thessaloniki as the lead partner, the Union of Science and Energetics from Georgia, the Union of Yerevan State University of Architectures and Construction from Armenia, and the Karadeniz Technical University from Turkey. The overall aim of the project is to develop innovative tools for the monitoring and management of sea regions with pilot implementation in all the 4 countries. In Greece, the study area is the Thermaikos Gulf in northern Greece, as you can see in the figure. And the aim of the project for the Greece is twofold. On one hand, to design and implement an environmental monitoring program in the coastal and sea area of the Gulf, and on the other hand, to develop an operational modeling and management platform for the study area. Regarding the environmental monitoring program, the aim of the program is to investigate and determine the current environmental status of the area of Thermaikos and to provide data which will be used in the modeling process. In order to evaluate the environmental status of the Gulf, we designed and developed 2 monitoring systems, a sea area monitoring program and a coastal area monitoring program. The first program, the Sea Area Monitoring Program, consists of 7 monitoring sites in all the area of Thermaikos Gulf, covering both the inner Thermaikos Gulf and some stations, the outer Thermaikos as well. 5 of these sites are located in the sea area of the Gulf and investigate the environmental status in that area. While 2 additional sites provide information about the inputs from the main freshwater sources in the area. The sampling frequency for that program is bi-monthly, while the parameters that are being investigated are presented in the list below. Regarding the coastal area monitoring program, the program consists of 7 monitoring sites alongside the coastal area of the Gulf. The monitoring sites cover all the area from Kalohori to the west up to Angelohori in the east and investigates the various natural and anthropogenic impacts in the study area. The sampling frequency for that program is monthly, while we investigate a number of parameters more likely in the sea area monitoring program. Here you can see some figures and photos from the monitoring exhibitions and also the monitoring sites, some monitoring sites in the coastal area monitoring program. These 2 monitoring programs will be concluded in August, where we have some preliminary results from the sites, but the actual data analysis will be conducted at the end of the program in September. The other part of the program is the operational modeling system that is developing in the area. This system simulates the various conditions of the Gulf and provide forecasting data and also will be able to investigate the impact of alternative management scenarios including natural and anthropogenic incidents in the study area. Here you can see a schematic of the structure of the modeling system. The system consists of the ELCOM model, which is the hydrodynamic model that is used in the development of the system. The WRF model provides the meteorological forecasting data for the system. Data from MyOcean platform used as initial and boundary conditions for the models. And the overall structure and operation of the system is being made by a WebGIS portal. The ELCOM model is the core of the modeling system. ELCOM is a numerical modeling tool that applies hydrodynamic and hydrodynamic models to simulate the temporal behavior of stratified water bodies with environmental forcing, and is used for the hydrodynamic and water quality modeling of the study area. The ELCOM model is developed in the study area with a horizontal cell size of 500 by 500 meters and a varying vertical cell size from half a meter to 1.5 meters. The simulation time step of the model is 3 minutes, while the initial conditions are the downscaling data from MyOcean platform and the results from WRF meteorological model. Here you can see the conceptual model of the Thermaikos Gulf with the cells of a size of 500 by 500 meters. And some indicative results are presented in the following slides regarding, for example, the seed density, salinity, the currents of the sea, and the temperature. The WRF model provides all the necessary meteorological forecasting input to the modeling system. WRF is a next generation mesoscale numerical weather prediction system that is designed to serve both atmospheric research and operational forecasting needs. The model serves a wide range of meteorological applications across scales from tens of meters up to thousands of kilometers. In the study area, the WRF model is deployed through 4 sequential grids of decreasing size ranging from a cell size of 30 kilometers up to a cell size of half a kilometer. During the operational phase of the system, the WRF model is executed daily with a time horizon of 84 hours, while the model's output data are provided with a time step of 1 hour. This slide shows some indicative results of the WRF model in the study area regarding temperature and the wind. Another key part of the modeling process is the downscaling of MyOcean data. The initial conditions for the development of the modeling system is obtained through the downscaling of the MyOcean platform, which is a platform that provides state-of-the-art information available on the global ocean and on European seas, and is based on the combination of space and in-situ observations and their assimilation into 4D models. The data that MyOcean can provide are temperature, salinity, currents, ice level, wind, and biochemical parameters. In our study, local historical hydrographic data were obtained from MyOcean platform which included the mean monthly values of dynamic temperature, salinity, horizontal velocity, and sea level variation. This data covers the period 1987 to up to 2012. And also mean daily values for the same parameters, which covers the time period of 2007 up to 2014. All these models are coupled and operated through a WebJS portal, which is developed with an open modular and entire architecture based on a number of open softwares like PostgreSQL, PostGIS, GeoServer, etc. Here you can see a schematic of the portal architecture, where in the left side we can see all the different tiers of the application, with the web tier, the application tier, and the database tier. All the data that we collected are presented via the internet through a user-friendly interface, as we can see here, where we can see that the layer of the map covers the most part of the application for an easy access and evaluation of the data. And the left panel presents all the different layers and all the different data that the application presents to the end user. The application, although in beta testing, is fully operational right now. Anyone can access it from the internet, and it provides forecasting data covering a period of 2 days for a number of parameters like seawater temperature, seawater density and salinity, sea currents, air temperature, and wind. As I said, the application is accessed by the internet, so you all are welcome to visit the application the following address and give us our feedback and any comment that you may have to improve the overall application. That's all. Thank you very much for your attention.
Thank you, Mr. Boskidis. Any questions?
Thank you. I have a question, just a clarification. This methodology from sampling techniques to modeling and forecasting is applied to the Thessaloniki Gulf. How does this correlate with the broader Black Sea Basin area? Are there any similar,
yes,
or is there any correlation, to what extent?
Yes. Every partner in the project will develop a very similar methodology for their part of the project, and the main and the final, let's say, target is to merge all these methodologies and access them by the same WebJS application as I show you the one from Thermaikos Gulf. So the WebJS application will merge all the data from all the partners and present it to the end users, to the scientists or the decision makers, all the information for the whole of Black Sea area.
Any questions? Actually, I have one.
Oh, yes.
This is also a DRAXIS program project, and you are ending in September, I think.
That's right.
But I want to hear, what did you find as problems and you suggest for the solutions? Or are you going to have the extension?
Well, we all hope for an extension, really. As I said, regarding the monitoring process, we are in the process of evaluating the overall program. We didn't have a whole year of field measurements, so we would like to close the field measurements in August in order to properly evaluate all the problems, let's say, of the Gulf. And then we will like to use the modeling process in order to evaluate different alternative management scenarios that will help us face the problems in the Gulf and evaluate different solutions for this problem.
So you need an extension.
We hope that we will be able to finish it, but we'll see.
Thank you so much.
Thank you very much.